acceleration is nothing but 0. So that means when the speed becomes constant, the acceleration is nothing but 0. So there is no force acting on the object. Now the part D of the question. Here, use the graph to calculate the approximate distance that the sphere falls, okay, between R and T. So this we want to calculate between R and T. So let's see in the graph. We know that in the speed time graph, the area under the curve or area under the line is nothing but the distance, because the speed is the distance divided by time. So the distance is nothing but speed multiplied by time, that we are already seen in the MCQ. So here I will draw here two lines between R and T. So I will indicate over here. This is the R and this is nothing but T, and we need to calculate the area between these 2 points. So we should calculate this area. This area we should calculate. This area in the speed time graph is giving you the value of the distance. So this is basically the area we have to draw this. We have to calculate basically this area. So this is approximately a rectangle. The width of the rectangle, that is nothing but from this point to this point. So here you can see the width of the rectangle is approximately from 60 to 100. So you can see 100 minus 60, that is nothing but 40 over here. And the length of the height of this rectangle is nothing but, you can see at the point R, it is nothing but, you can see on the y-axis it is nothing but 120. So the area of this rectangle is nothing but this height into base. This is 40, this is 120. So we can write down. So we will write down here the distance is what? Distance is nothing but distance is equal to the speed multiplied by time. Okay. This is nothing but the area. This will be equal to, we can write down, this will be equal to the area of rectangle area, and that is nothing but height into base, and that is equal, height is nothing but 120, base was nothing but 40. So final answer you will get over here. This value you will get. This value is nothing but 4800, and the unit is nothing but meter. So here I will write again 4800 meter. This is nothing but the distance between the point R and T. Now we want to calculate the same distance covered between the point here P and Q. So again, let's see in the graph. So in the graph you can see this is point P and Q. So P is nothing but at the origin, Q is over here. So here we need to estimate first of all what is the area over here. So this is nothing but the area, and this area is nothing but of the triangle. You can see approximately this is a triangle. So we want to estimate this particular area to find out the distance between point P and Q. Okay, so this is approximately the triangle, and the area of the triangle is nothing but half into base into height, and you can see here base is nothing but, this is covering the 3 divisions over here at the bottom. So here you can see the 10 is at the 5th division. So you can see 1, 2, 3, 4, 5. At the 5th division it is 10. So at the in the 3 divisions it must be 6. You can consider this is nothing but the 6. The time is nothing but 6 seconds. The height over here you can see it is coming out to be on the y-axis over here, and this is between exactly at the midpoint between 40 and 60. So it should be considered as a 50. So here base is 6 and the height is nothing but 50. So we can write down. So we will write down over here the distance is what? Distance is nothing but the average speed multiplied by the time. Average speed multiplied by time. That is nothing but the area, and this is nothing but equal to, we can write the area of the rectangle, that is equal to half multiplied by base into height So we can write down that should be equal to half multiplied by what is the base? Base is nothing but 6 and the height was nothing but 50. So that calculation, if you do this calculation, that calculation is coming out to be 150 meter. Okay. So you can write down over here 150 meter. So our speed line was not a horizontal line, and like in this case RT, it is what was constant speed was there. So I have written only the speed, but here the speed was not constant; it is increasing. So instead of that, I have written over here the average speed. Okay. So in that case, it is better to write down the average speed because speed was not constant over there. Okay, so you have to write down always the formula and then the area under the curve or under the line to calculate the distance. Now we will see the second question. So you can read here. Figure 1.1 is a distance time graph showing the motion of an object. And first question in part A, here describe the motion shown for first 2 seconds, calculating any relevant quantity. So we know that it is a distance time graph basically, and in the distance time graph, the slope is nothing but giving us the value of the speed, giving us the value of the speed. So if I consider here, if suppose this y-axis and this reference figure, if suppose this is the distance and the x-axis is nothing but the time, then the slope is nothing but the speed. And we know that for constant lines, these are the constant lines. These are the straight lines. For the straight lines, we get the constant slope, and here these are the curved lines for which we get the variable slope. So here this is a distance time graph. So slope of this line is the speed, and you can see this is the straight line. So speed must be constant. So first point we can write down always over here the speed is constant. Speed is constant, or you can write down the speed is nothing but the uniform. Okay. Speed is nothing but uniform. Now we should calculate what is the value. Okay. They are also expecting calculating any relevant value. So we know that relevant value is nothing but the speed, and we need to calculate the slope of this line so we can understand what is nothing but the speed. Here we can consider this line, this point, and we can consider these 2 points. Okay, for the calculating the slope, we always need 2 points. This is the first point I'm considering, and this is the second point. So how to calculate basically the slope? Here we can write down here the speed is nothing but, you can write down speed is nothing but the change in the y-axis divided by change in the x-axis. That is nothing but the formula for the slope. So y-axis, you can see it is going from, if I consider these two red dots on the y-axis, it is going from 0 to 5. Okay, so change in the y-axis, that is nothing but the change in the distance. We can consider this is the number 5, and change on the x-axis, it is going from 0 to 2. So it is, I can write down 2. So 5 divided by 2 is nothing but 2.5 meter by second. So our slope value is nothing but 2.5, that is nothing but speed. So here we can write down the average speed is 2.5 meter by second. Again, the speed is not constant, it is increasing. So instead of writing down the speed, it is always better to write down the average speed. Okay, so we can consider the average of all or average of this entire line, that is nothing but the slope of the line, that is nothing but 2.5 meter by second. So we have to write down 2 points for the 2 marks. Now the second part, you can see after 2 seconds the object accelerates, and on figure 1.1 sketch the possible shape of the graph for next 2 seconds. So here the main important point is nothing but the object is accelerating. So you can consider at this point, this is the distance time graph. So the slope is nothing but speed, and speed is constant over here because this line is nothing but straight line. We know this for the straight line the speed is constant. So for first line we can consider For this first line, the speed is constant. So for the constant speed, we know the acceleration is zero. Okay, our acceleration